Good morning, sunshines. Today we're going to talk about sound. Yay! Again, one of the things, you're not a sound designer. You're not being paid as a sound designer. But in a lot of theaters, because sound is handled through electrical impulses the same way lighting is, they assume that you, as a lighting designer, know anything about sound. And so I'm going to tell you a little bit about sound. This is, as I told Cody, it's just going to get to the edge of what he knows and frustrating because I'm not going to get in depth into any of this stuff. I'm just going to let you know what some of the stuff is called and how it can be typically used. But we're not going to get into any too depth because, of course, you can have an entire semester of sound design class. But first of all, let's just talk about physiologically what sound is. Sound is a movement of air. One of the things about sound, if you have a vacuum, you have no sound. Does light travel through a vacuum? Very nicely. Does sound travel through a vacuum? Nope. Sound needs to have the atmosphere in order to create the waves that are called sound waves. They move much slower than light waves. And as opposed to light, which is both rays and bundle of energy called photons, sound is merely a wave. First of all, let's talk about the sound wave. It has a frequency, in other words, the number of times that you have in a sort of a second, number of ups and downs, but it also has a height to it, yes? And so that's called the amplitude. Frequency is the length of the curve. Amplitude is the height of the curve. The more frequent the frequency is in a sound per second, the higher pitch the sound is. The more amplitude you have, the louder it is. Yes? And so those are the two components of what's called a sound wave. Now the way, let's just talk physiologically about what we hear, how we hear sound first, and then we'll talk about how we produce it. First of all, you have the things called ears. Usually there are two of them. A perfect ear has all these components. Sometimes, as you know, with colorblind people, there are people that have parts of the spectrum that they can't hear. As a matter of fact, you may have heard my story about how it is that husbands can't hear their wives. And my belief is that in our entire life, we have this inner voice as little boys that has told us all these stupid things to do, like, put the cat in the microwave or come run, jump in the mud puddle. And your mother has slowly but surely beaten you so that you don't listen to that inner voice. And then you meet this woman who speaks to you, and for some reason you can't explain, you fall madly in love with her. And I'm going to tell you it's because she speaks with that child's inner voice. But because your mother has beaten the ability of you to hear that voice out of you, it means I love you even more. You're more part of my soul. Say it sincerely, it works. Anyway, the human ear, you have the ear canal. Of course, one of the things you can have is a Q-tip stuck in there or something crazy. Of course, if you don't know it's muffled, you don't know it's muffled. But eventually you get down to the eardrum, which again is a little fiber that vibrates. And that vibration caused by the sound that it hears connects to a hammer and an anvil, and through a chemical means through the stirrup, it creates an electrical impulse that goes to your brain, and your brain has learned to interpret those electrical impulses as a sound. Yes? So that's one way that sound works physiologically, through your ear. The other way is through your vocal cords. It's a very different way of producing sound. Yes? Now, your vocal cords, if you look at the drawing there, are two very tight muscles that are found in your esophagus, in the trachea, and they can expand and contract. That creates they create the frequency. The wider they are, the higher the frequency. The lower the frequency is. When you bring them very tightly together, it allows less oxygen to come out, and the frequency is diminishes. You have or increased. You have a higher sound. The other way that we can create sound is through the use of our diaphragm. In our muscles underneath our lungs, there's this muscle called the diaphragm, and the amount of air pressure that the diaphragm puts on the lungs increases or decreases. How's that?
Excellent.
Yeah, thanks. You're welcome. The amplification. So that doesn't change the pitch at all. That has nothing to do with frequency. At least I was trying to do that. The amount of air will increase or decrease the amplification. Yes, and that is the way your vocal cords produce sound. Your eardrum still works the same way. And why that's different, or why that's important to us, is because there are two different ways of creating speakers we're going to talk about in a little bit. And one of them uses the eardrum method, and one of them uses the vocal cord method. Yes, and they both have their advantages, disadvantages. We'll talk more about that. But that's why we have to why we introduce that. All right. First of all, let's talk about what hertz is. Just like a lumen is a measure of light, a hertz is a measure of sound. The more frequent the hertz is, the higher the pitch. 1 hertz is equal to 1 sine wave over 1 second. That's what 1 is. Take a second. If it takes a second for the sound wave to go up and down and back to 0, that is the sound of 1 hertz. If it can be slower than that, in which case you have a much lower sound, or it could be most sounds are much higher than that. And so most sounds, as a matter of fact, again, most sounds that we deal with, 50 hertz is really the lowest sound that we can reproduce with the speaker system that we have. You have to have really good subwoofers to get down to 5 and 0 and only 1 hertz. So 1 hertz is really low sound. It's a hum. Now, decibel is the volume, is the amplification. Yes, so a hertz is the frequency. Decibel is the loudness. Those are 2 measures of sound. Cool? All right, again, there's a little diagram there showing you what 1 hertz looks like and what 10 hertz is, just to give you the idea as frequency over time. There are 4 things that a sound designer does. One is support reality on the stage. If somebody looks to the sky and says, oh, I hear a plane, it helps to have the sound of a plane overhead. if somebody falls to the stage with blood on their chest, it helps to have a gunshot off stage so that you know why the person may have been falling on the stage with blood coming out of them. Yes, so there's supporting the reality, sound effects. Again, you can even create the mood. That's the second thing. You've heard it mostly in movies, but also in theater. When 2 people look at each other and suddenly start hearing violins. Those aren't real violins, typically. If it's a Mel Brooks movie, it is. But on stage, the violins start playing at a very low level when the 2 people's eyes meet, because you are reinforcing the idea that they have fallen madly in love, if that's what's going on. Maybe you hear the shriek of Psycho when they look at each other, when they hit each other. You're also creating the atmosphere. Things like crickets, sound of crickets you're creating nighttime. Whatever ambient noise you may be having, all the ambient noise that we have in the hallway here are the reality of what's going on here. Maybe sound like a mower outside or something crazy going on, you never know. But it's the ambience saying that this is the reality we're in, right? Those first 3 elements, like a door slamming, require you to do research and find a specific sound cue. The other thing the sound designer does is reinforces the sound the singer. So we'll talk about microphones, body mics, that sort of stuff. You're not actually finding the sound cue and creating the sound cue with that. You're actually, many times, it's like playing a keyboard, you're actually raising and lowering, because again, singers have a typical sound that they make, but let's say they've been singing 7 shows a week for 10 weeks, and they make it a little gruff. It may help to boost their sound a little bit so they fill the auditorium still, and they're not singing as loudly. You're helping them more, giving them more sound support. So again, it isn't always that you can pre-record all that, but you can get a good idea, especially turning muting mics and all that sort of stuff. You can pre-record into modern day sound boards. Yes, but we'll talk briefly about that, but know that sound operators are the ones that deal with that more often than sound designers. Other than finding a particular type of microphone you're going to have and that sort of stuff, you don't have a whole lot of input on that. That's mostly the sound operator's job. All right, there are 2 ways to make sound. Yay! Live and recorded. And that's a big choice. As a sound designer, what works best? I can guarantee you There is no recorded sound you're ever going to find that sounds like a real gunshot. Ooh, or a real phone ring. A gunshot just has a certain decibel level that you cannot achieve with recorded sound. It just peaks, is what it's called. It just gets too loud of a sound to come out of the speaker. It's too quick, too sharp. Now, I have been able to reproduce the sound of a gunshot live without using a gun. If you take a 2x4 and bang it against this table, it will sound like a gunshot, especially if you don't see somebody in the wings hitting the board on the table. To the audience, it will sound like a gunshot, especially if the guy falls down with blood falling out of him, and somebody else says, "Oh, that gun! Somebody just shot that gun." It adds to the reality of it, but it's not a real gun. Again, you can also find a real gun and use blanks. That would probably be my last option, because that can become very dangerous. And there are ways of achieving that without having to have the real gun, but sometimes you just have to have the real thing. So live is sometimes best. If you're creating thunder and lightning, there are old school ways of taking a big piece of tin and shaking it and creating thunder, and having the light designer work with you, again in collaboration, to have the lightning go off. And so again, you can create those effects live. If you are creating for any effect, have a backup. Have something that will make noise, because a lot of plays, for instance, let's just talk about phone calls. A lot of plays, if there's a phone ring in the play, whatever dialogue they were in stops because they go to answer the phone. Now, I don't know about your house, but in my house, we don't do that anymore. The phone just rings, which I think is hilarious. Phone rings and nobody even says phone. We just don't answer the phone if they're calling our home number because it's somebody trying to give us money or get us to give money. And if they leave a message to somebody else, then we'll call them back. But nobody answers the phone in our house. Now, they'll answer the cell phone, sure. The cell phone goes off and you gotta grab it. But your actual home, my landline, we hadn't answered that thing in years. But in most plays, that would be an odd choice. The phone rings, you stop, you go and you answer it, yes. If the phone doesn't ring, there's no dialogue for the actors, because the dialogue is hello. Yes, and so the actors are having to cover on stage while you're trying to find, because somebody forgot to put the handset on the phone just right and your electric ringer doesn't ring, or your cue brings up crickets instead of the sound of a phone ringing. You hit the wrong cue or something. You need somebody backstage with just any kind of bell. Anything works. The worst come to worst, go ring. I actually did a show once where somebody went bang. Couldn't find a way to make a noise or whatever. Somebody said bang. The guy fell down. We were able to do the show. But we were stuck until somebody came up with a way to shoot the gun that didn't shoot. Yes? So have a backup, live and or recorded, have a backup. Now, once you've decided to go through a system that is using recorded sound, I've given you a little step-by-step thing here, and the reason for it is because when things don't work. If everything works, then it works. If it doesn't work, one of these things has got something wrong with it. We're going to talk about each of these steps as we go through. First of all, you have to have a source. You have to have something to play back the sound. That source is going to go through then a cable, which is going to go to something called a mixer. The mixer allows you to change and or amplify and or do some things. We'll talk about that. And then it's going to go through another cable. And you're going to go to something called an amplifier, which helps boost the level of the sound so that the speaker can hear it. And sometimes there's a cable between those two and sometimes not. Some speakers have amps in them and they're pre-wired. We'll talk about that too. And then it has to travel from the speaker to your ears. And again, sometimes things get in the way of that. Yes? And so we're going to go through and talk about each of those steps independently and how each of them can affect the sound that you're working with positively or negatively. First of all, let's just talk about some sources. I've given you 3 sources here. There are hundreds of sources. Your Walkman. How old am I? Your iPhone could be a source. You can plug in your iPhone, hit play, and you can create sound on stage. So I'm going to point out a reel-to-reel, which is really old technology. I'm talking about 50s technology. And one of the reasons I pointed it out is because reel-to-reel tape is still the easiest way I have found to edit sound together. To make it, if you need a sound to stop on a dime, go find some reel-to-reel tape and edit it on a piece of leader tape at the end of a sound cue and by God, when it gets to that sound, it will stop dead. But the tape will still keep running because you've got leader tape in, but leader tape makes no noise. Yes, and so you will occasionally find that reel-to-reel tapes are the best option. Yes. Now, just so you know, a reel-to-reel tape has a head like a cassette tape, which you don't know what that is, or an 8-track, which you don't know what that is. But there are 4 tracks on reel-to-reel tape, 1 and 3 and 2 and 4. When you flip the tape over in the system, the head on the reel-to-reel only reads 1 and 3. So as 1 and 3 are going through this way, when you flip it over, 1 and 3 have now become 2 and 4, and so that's why you can have 2 recordings. You record something on this side of it, and you can record something on that side of it. Most people are only going to record on one side of the tape. But occasionally, what happens is you'll see something on the box, especially old days, that says that something's on it, you can't find it, flip the tape over. It may be on the other side of the tape. So there's that. CD player is most common. Other than that, you've got a great thing about CD players is that they're digital and the sound is very clean. You don't have a lot of hiss. You don't have, record players, again, nobody knows what those are, but they have a little distortion in them just because of what they are. Cassette tapes, 8-tracks have distortion. CD is very clean and is digital. Anytime you get a digital signal, it's clean, you're in better shape. The biggest problem with CDs is that there is a delay. And so usually what you want to do is get to the cue and hit pause, and instead of hitting play when you get to the cue, hit unpause. That'll pick up quicker than if you hit play. If you just if you put a CD in and hit play, it takes a second for it to find it and to go. Even if you've just gotten there and you hit stop, it'll still go back from 1 to find it. So if you get to a point where, let's say that the sound cue happens at 15 seconds into this song, go to 14, hit pause, and then when the stage manager says go, hit unpause, and 15 will be the first sound out of the box. But again, that's what I'm talking about with reel-to-reel tape. You don't have to worry about the leader into or out of the cue because you're able to edit it. And CDs, you're stuck with whatever sound is coming out at that point. And really you have, a second can be a long time in sound design. Yes. What we have is a computer. We have an Apple computer that has what's called ProSonus sound editing equipment on it. The nice thing about that sound editing equipment, it's very user-friendly. You download the sound into the ProSonus, and then you can take it and you can alter the pitch, you can alter the time, you can edit it just like we talked about with editing a reel-to-reel, have it stop at a certain moment and get rid of the rest of the sound. You can layer it. You can have one thing happening on one, you can actually send that to one set of speakers and send something to another set of speakers. So let's say you have somebody playing the violin in the top floor of the house and a car pulls up, you could have the violin playing over here and be in the same sound cue, have a car pull up on this side of the stage. And it will come out of those speakers. It's just something you just assign in the course of editing the equipment. So that's the great thing about sound editing equipment is it gives you a lot more variety of what you can do as far as the sound, but also the distortion of the sound. You can take sounds and expand them, contract them. Again, anytime you contract it, it changes if you take a frequency and you make it faster, you've made it higher. You sound like Minnie Mouse or Alvin the Chipmunk.
Yeah.
You've gone from speaking over 10 seconds to speaking over 2 seconds, and now you've altered the pitch of the sound. Yes. So again, you have to be kind of careful when you do that. I would always suggest recording and downloading where you are before you start doing the editing. So that way, if you hit a button that says dump all for some reason, you haven't dumped everything. You still got it that you can reload it back into the computer. Yes. There are lots of little videos about how to work the ProSonus and online, and I would encourage you, if you're interested, to go and watch those. Yes. Now you're going to go from the source through a cable to the mixer. Now, the cables that you can go through, there are 3 basic types of cables. Again, the wire within the casing is the same. You've got a 12 gauge wire typically. RCA cables are probably 8 gauge. But for the most part, it's copper, just like it is in lighting, which again, why you wound up doing it as a lighting center. The most common type of sound cable is XLR cable. It's a microphone cable. It has 3 pins in it, X, L, and R. The X is the ground, and it is the center of the 3. The left is to the left of ground, and the right is to the right of ground. You can see in the picture there's a male and a female side. Typically, your light board, or your sound board, will have the female receptacle, and what you want to do is plug the male receptacles in. Your microphone will also have the female, and so in most cases in sound, not in lighting. In lighting, there's always a tail that goes from a male to a female that goes into the plug. In lighting, it's always male to female, male to female. Even if you have an adapter, it goes male to female because you have to plug it into the same source. In sound, more often than not, you have male to male plugs. You go from a microphone, which is a female receptacle, to the mixer or to the source, which is a female receptacle. And so most cables are male to male, but there's an example of a male to female plug. You can also see there's a little, I don't know if you can see it, but it's there. There's a little thumb on the female side. There's a little piece where you push down it and it locks into the little groove that's on the male side. So it's nice and sturdy when you plug them in. It makes a little click, yes? The next type of cable is what's called RCA cable, because of course RCA came up with it when they were trying to find ways to build their stereos. If you've ever had a stereo, it's the one you just push and it holds from gravity. It's a little crimped. There typically are 3 colors: red, white, and blue. Red, white, and yellow. The red typically is the left channel, the white is the right channel, and the yellow is video channel. If you have a video, that feeds the video side. If you don't have video, you use left and right. You want to always make sure that you plug your left into your left and your right into your right, because it will work the other way. You know, it's just cable, it's electricity going through cables. So if you plug your left speaker wire into the board on the left, but into the right side of the speaker, it'll send the left message to the right side of the speaker, no problem. So that's why they're color coded. So the left is always on the left and the right is always on the right. The other type is what I call quarter-inch plugs. This is mostly used for instruments, for guitars, for basses, for those electrical guitars, plug into those type of amplifiers. There again are adapters that you can take from a quarter-inch cable to an XLR cable to fit into your light board. But most soundboards, and I say light, I mean sound, but most soundboards will have a port for an RCA, an XLR, and a quarter-inch plug. Again, other adapters, other 1/8-inch plugs are the ones that are for your iPhone. There's all kind of other cables that may be out there depending on what your source is. Cool. So that's the cable from your source to the mixer. Now let's talk a little bit about mixers. Yay! There are some mixers that are really, really complicated. And I'm talking about 6 feet wide, 4 feet long, or 4 foot width, yes? They have hundreds of channels. If you think about it, again, just use Hamilton as an example, there are 25 cast members, all of whom, I promise you, have 2 microphones. On Broadway, they have 2 microphones each because if a mic goes dead, you don't have time to change that microphone because of what how busy they are. So you'll have 2 microphones, one in case the battery goes out in the other. Yes, you'll have a fail-safe. The same thing on television shows. There will always be 2 microphones right here because there are 2 mics packs. Because if you're in the middle of a live broadcast, you don't have time to go and change the battery if the battery goes out. So if all those people have microphones and all of them have 2 microphones, that's 100 microphones right there, or excuse me, 50 microphones. And then you have to have things like playback for your Sonoras, Personas, whatever it is. Yes, so boards can get very complicated very easily. Our board has 14 channels. And again, on our board, we typically will have the first channel reserved for a live mic, so that the stage manager can say things like hold, or we need to vacate the theater, or there's been an accident, or whatever announcement, somebody's lights have been left on. Whatever announcement the stage manager might need to have during the course of the show, that's always on pot 1. Well, before we get into mixers, let's talk about a potentiometer. Really what a mixer is a series of these things called potentiometers. Now, because of that, the short version of that is a pot. Now, live boards today are digital, and so it's a computer. And so they no longer have potentiometers. But in the old days when you had a dial, a potentiometer was a way of reducing and limiting the sound. And because that's the way it was set up, the reason that it's important to us is because the digital sound works the same way the potentiometer worked, and that is that whatever the feed is given to the mixing board, it's given to it at the level it was recorded, at 0. So when you're looking at your boards, your faders, the 0 is going to be very high up there. And then what the potentiometer does, what the fader does, again, the fader does it through computer means by digitally telling the signal to be less and less. The potentiometer just would let less electricity through, but they're using the same idea. You're limiting the amount of sound that's leaking through the system, basically. And so when we're talking about the mixture, you're going to see that the scale goes from a minus, the bottom is going to be minus 80, minus 90. And then you're going to go up to 0, and then you're going to have a plus 20. Some of them will go to plus 10, but there's going to be a plus side, right? The first thing you want to do is turn the board on. If the board's not on, it's not working. I know that sounds simple, but I can't tell you the number of times when people call me and say, Michael, can't get any sound. Is the board on? Oh, well, thanks, bye. So make sure the board's on, and you want to make sure the mains are up. Now, in a typical soundboard, there are 2 or 4 masters is what they're called. And the reason for that is because there will be a master for the left side, the left speakers, and for the right speakers. If there are 4, it's because there are 4 speakers out there. Yes? And so you'll have 2 for the left and 2 for the right, and a lot of times there's a little plastic thing that'll go over both of them so you can lift them at the same time. In the example I've given you here, there's a little board that just has 2. You want to set the main at 0 as much as possible and leave it there and don't ever change it. Because as soon as you start messing with the 0, you've changed all the levels of every sound cue you've had. So leave that at 0 and adjust the faders for each source separately based on the amount of sound that has in the light cue, or in the sound cue, excuse me. Now, the reason that it's there is because occasionally you have to use the main because it's a solution. And so if you absolutely positively have to, I mean, let's say you've got 10 sound cues all running at once and they all got to go to 0. It's just, you got 10 fingers, let's say you got 11 of them, you have to use your elbow. It's just so much easier to bring down the main than to bring down all those faders at once. Yes? Now, if you've got a computer board that records, you can set the levels at 0, record it, and then all you gotta do is hit a go, space bar on your computer, and it's great because all the faders change because they've been recorded that way. Yes? Now, again, your faders can get you in trouble because sometimes sound doesn't reproduce the way you think it should, or things have gotten muffled, or something is in the way at the final step. We'll talk about that when we get there. Yes? So the first thing is we're using to make sure it's on. Second thing, make sure the mains are at 0. Then you plug in a source, however many sources. Again, you've got your XLR, your RCA, and your quarter inch. You plug it into the back. Each potentiometer will control that source. Again, the board that you've shown there only has 4 sources. We've got 14. Yes? The first thing you want to do is make sure there's a button there that says mute. Right above the fader, it says mute, usually red, and usually if the LED works, it's on. If it's pushed, it'll be on. So you know to turn it off. But again, I can't tell you the number of times where the answer has been, is the board on? Yes. Is it been unmuted? Oh, thanks. Because if it's muted, you will not send any sound energy anywhere. So unmute the fader, and then as you fade it up to 0, it'll increase the sound. As you fade it down to minus 80, minus 90, it'll decrease the sound. At least the one that's being let out. If you go above 0, you are sending more energy out than was received by the source. And that's where you get fuzziness. That's where you can get distortion. That's where it sounds like you're talking to a tin can. Because it is louder, but the loudness is distorted because it's more energy than was there. So always record your sound at as bright a level, as high a level as you can. It's always easy to limit it. but it's awful hard to throw any more in. And so if you have some problem with distortion, it's because you've gone above 0. There are 3 knobs on this example. In some examples, you'll have 10 knobs that will control, again, from about 50 hertz to around 2,000 hertz is the low end, about 1,000 hertz is the low end. From about 1,000 to 2,000 is what I'm gonna call mid-range, and from about 2,000 to 10,000 hertz is what I'm gonna call high end. And each of those buttons will control that part of the spectrum. Again, if you've got a board that's got 15 of those knobs, each one will do about 100 hertz. And so you can really fine tune and really make the sound a quality sound and mimic things. A lot of times, for instance, 2 people's voices aren't the same, but people get used to hearing somebody's voice on the recording, and so you may be able to alter the sound of somebody's voice to give them a little bit more high pitch or a little less low pitch, etc., add more low, and make them more similar than they would be if you hadn't gone through a mixture, for example. It's another way, again, of taking, when we did, what was this show where Greg Thornton did the pre-show announcement, and we distorted the sound to make it sound like it was a chipmunk kind of thing. Anyway, it was just done through the mixer. Because he didn't want any people to know that he'd been recording. Anyway, so those again are the high, mid, and low range. There's also a knob at the very top that we don't talk about that switches from microphone to source, just says mic and source. The reason for that, remember we talked about the difference in quality of your vocal cords versus your eardrums? The reason for that switch is because that's the difference. The microphone sends a signal that's just different than a source a computer will send. A digital signal is just different than an amplification from a microphone. And it helps to tell the board, you're not looking for this stuff, you are looking for this stuff, or you're not looking for this stuff, you're looking for this stuff. So there'll be a switch microphone to source, and just make sure it'll still play the other way, it just won't play as distinctly, yes? So use your fader up, adjust your high, your mid, your low. The gain, if you've got some sort of, it increases the volume, it increases the amplification. It increases the volume is what gain does, or decreases if you turn it down. If you have a sound that's muffled, again, it could be because it was recorded poorly. You can slightly adjust. The gain will slightly adjust and make it a clearer picture. It's like putting glasses on. I mean, I can still see the camera, but I see it much better here. That's what the gain does. It's like putting a little set of glasses to fine tune it. It doesn't do great distortion. It's not gonna make it a blackout or sunglasses or something like that, but it will give you a fine tune. I would always have the gain again at 0. Because especially if you've just done a show and you had to switch the gain to far left or far right, and you come back and you start playing different sound cues, and it's like, why does this sound so weird? Oftentimes, it's because the gain wasn't set back at 0. Because you're using the gain that you had adjusted from the last show you did. So one of the things you need to do when you reset a board is just set everything to 0. First thing you do, all the lines, when you look up, every one of them wants to be straight up and down. And that way you can adjust left to right from that center point. The pan, the lower button on the list, again, there may be 3 to 15 different knobs for the high, the low, the mid. But the button at the very top is always going to be the gain. The button at the very bottom is going to be the pan, and that moves from left to right. Again, if you have, if you've ever listened, what's the Queen song where they sing, they're battling back and forth.
Bohemian Rhapsody.
Bohemian Rhapsody. I'm just a poor boy, nobody loves me. I'm from a poor family who gave me his life. Anyway, you can make it all go one way or all go the other by just switching the pan. Now, will you hear a little echo of the other one, the other channel? Sure. There's still some energy that goes through, but it will do a very good job of limiting that. Again, one of the problems is people have left the pan, if you're not up and zip down to 0, you've left your pan move. If you're trying to get, especially if you're trying to get the car to come in stage right, and you got your pan set on left, it ain't gonna work, because there's no sound energy going that way. So you're fighting yourself, yes? Here's a big one. There's a button next to the mute button called a solo button. What you do with a solo button, if you're listening to several sound levels, and you just want to hear that one and not the rest of them, instead of muting all the rest of them, if you just hit the solo button, the only thing that's going to send to the speaker is the solo button. So just as I said with make sure it's unmuted, make sure that all the solos are not lit. The solo is usually green. The mute is usually red. Again, the other thing I found is on boards that are a little bit older, the LEDs don't work. And so it will be depressed without you knowing it. Usually if it's up and high, it is not depressed. If it's down, it'll catch. It'll catch in a low position if it's been pushed down, yes? And so the solo button will allow you to just hear that one channel by itself. Cool. You're going to use the same out cables as you use in cables. Typically, again, you're going to go to the mic cable because that's the one that's most typically used as speaker cable as well. We'll talk about another speaker cable here coming up on tours and that sort of thing. You're going to go from that to the amplifier. Again, you can see there's an example of an amplifier. Some amplifiers are going to have, again, if you only have a left and right channel, you really only need 2 pots. You only need 2 entries. One for the left side, one for the right side. Again, you may need to double them, so you put 2 speakers on the left and 2 speakers on the right. But you don't need a whole lot of source. Every source can go into those. The one main can go straight into the amplifier. So you set the amplifier at a level, and then you adjust from the mixer. While you can adjust the amplification on the amplifier, just like with the main, you want to avoid it at all costs. Now, having said that, if your amplifier is turned down, no matter how loud your mains are, you're not going to get sound. So the other thing is, if some idiot has come along and just turned all the buttons willy-nilly, or vice versa, turned it all on, no matter how little sound you're producing over here, suddenly the speakers blow because somebody's, usually they don't put out that much sound. But that's what an amplifier is. It boosts a little bit of sound so that you can get a little bit more energy, especially over long. Again, think about it as blowing air through a straw. If your bottom of your cup is here and you're blowing, it's easy to make bubbles. If suddenly you got a straw that goes all the way from here to the end of the glass and you're blowing this in, is there air flowing? Sure, but the volume of air isn't enough to create enough bubbles over there. And so you need a little bit of push for the amplification in order to get all the way to the speaker and be of the volume that you are here. Now, again, I'm talking hundreds of feet. If you've got a theater and you're 50 feet away, you're fine. But an amplifier, and a lot of times the amplifier will be in the speaker. They will combine the amplifier and the speaker. Those are what are called powered speakers. They will have a separate Edison cord that you have to plug in, and there will be a couple of knobs for your amplifier on the back, and there'll be an on-off switch for your amplifier on the back of the speaker. Cool. All right, so you've got a cable, usually the XLR cable. You'll also see there's speaker cables, especially on tours. Those speaker cables are really quick at moving and plugging in because all you need is, you don't need the ground on this because the whole system is grounded, and that's why the blue speaker cables are just easier. You just plug in and it's ready to go. Yes? And again, they're just quicker, easier than having XLRs, which can break. You have the solder that could break, all kinds of things that can go wrong with XLR cables. And so on tours, especially, you want to have those blue speaker cables. And you can see there's a little thumb knob to attach and detach them, just like you did with the XLRs. Okay, let's talk about speaker. Speaker has potentially 3 ways of creating sound. I would tell you that in a lot of speakers, they don't have a mid-range. The mid-range is usually the first thing to go, and all you have is a woofer and a tweeter. Again, the tweeter is going to produce sound. Anything above 2,000 hertz is going to be produced by the tweeter. Anything under 1,000 hertz is going to be produced by the woofer. And if you have a mid-range, it's from 1,000 to 2,000 hertz. Again, you can adjust the levels of each of those on the mixer. Usually, most speakers don't have a way of adjusting. There occasionally will be a speaker that will be a really expensive speaker that will also have a mixer on it. But for the most part, speakers come and just receive the information that you're going to get from the mixing board. Again, the way they work is the same way a microphone is going to work. We'll talk about it a little bit more when we talk about microphones. But basically, you have 2 magnets that are a distance apart. And what happens is when the magnet pulls this magnet towards it with less or more energy, this magnet is creating with the woofer or with the tweeter the same sound wave that was recorded on the initial device. And again, we're going to talk more about the microphone and how to record that in a second. But that's basically what's happening with the electrical device there. Now, let's talk about, for 2 seconds, Bose technology. The way I just described that is the way your ear works. Eardrum makes a sound wave, hears a sound wave, sends the electrical signal. The electrical signal is sent to the magnet creates a woofer creates a low sound, tweeter creates a high sound. That's the way your ear works. The way a Bose system works and the way your vocal cords work by becoming thinner and thicker is the way a Bose system works. So a Bose system is really good at creating and recreating things that are like guitars, like pianos, like voices. The problem is it creates them at the sound that we're listening to them. It is not good at all at amplifying that sound. And so when you get into venues that are larger than a room, you got more than 10, 15 people listening to you play music, it's gonna sound much better on a Bose system than it will sound on a standard speaker system in a small environment. Bose systems are great. In your home, Bose blows them away. Yes, but the problem is you really can't transfer that because your ear will adjust to loud noise, but your vocal cords can only make so much noise. You can only get them so tight together before they start to stretch or to start to have leaks in them, that sort of thing. So that's what's happening with the Bose system. So Bose systems really aren't transferable to theater for theater purposes. But if you're using it for a small venue or for a band in a small location, occasionally you're going to come across a Bose system. The plugs are the same, everything is about the same except the way the sound is created. Even your knobs are going to be mid, low, and high, but they're just, instead of creating them with woofers, you're creating them with cylinders that have bladders between them and a coil in between. Yes? But again, Bose, if you've got a Bose system, you can go get a Bose technician. Yes, all right. Let's talk about microphones. Yeah. There's that choke. Okay, here's your diagram. There's your front plate, there's your back plate, you got a battery, you got an incomplete circuit, you're creating a little electrical arc. If the two plates touch one another, if they actually come in contact, you're going to get a loud buzz. And oftentimes, mini microphones, it's people call it peaking, but if you let it last too long, it'll ruin the microphone. Yes? So you really don't want people going up and going, yelling loudly into a microphone is a horrible thing to do. Dropping a microphone is a horrible thing. Anything that makes a nice, loud sound right at the front of the microphone can do horrible damage, even if the microphone's not on, because the magnets are still there. And even if you cause the magnets to touch, when you turn it on, they're going to continue to stay touched because of the magnetism that may, when you've done this, when you touch a magnet to another magnet, it demagnetizes it, or adds magnetism to it, whichever way you're going to do it. Yes, so you've got the two magnets that produce the electrical signal. The electrical signal is what becomes the recorded thing on your tape or on your computer. And again, the computer records a digital signal, whereas your tape records an auditory signal that reproduces through the system we've talked about. Cool. There's basically two types of microphones. There's condenser mics, dynamic mics. A condenser mic is very fragile, much longer along the system of a Bose system, but it has a coil in it as opposed to a magnet. And so dynamic microphones tend to be omnidirectional. You tend to pick up sound all the way around, whereas a condenser mic tends to be unidirectional. It tends to be able to point the microphone and just pick up what's right in front of it, and it tends to record sounds that are much more pristine. In other words, because you're not doing the ambient stuff, you can get a lot more signal on a lot smaller microphone. And so body mics, for instance, are condenser mics. The problem is water does damage to it. And so, let's talk about wired and handheld. Again, one of the things about modern technology is that we're able to send radio signals to all these things, and so you can have a handheld microphone that does not have a plug in it. It's got a little signal sender, there's a receiver and a sender, and you can send a little radio signal for 50 feet, for 100 feet. The problem with that is that a lot of times those channels can also be invaded by CBs on the highway. You can start picking up, or occasionally bank tellers will also use that sort of information. And so you may wind up with some arbitrary sounds. But again, because it's just a local receiver and a local sender, it doesn't tend to have that problem unless you're just sitting next to some sort of highway or that sort of thing. But again, handheld microphones are great. If you're ever working with a handheld, I would always wrap the microphone in a piece of electrical tape, red, blue, yellow, that sort of thing, and then on the mixer board, have the red, blue, yellow tape. Because a lot of times you may say, here's your microphone, and the actor says thanks, and they'll put it down and go backstage. Instead of the red microphone you gave them, they now have the yellow microphone, and if you have tape on it, you can look at it and see, ooh, they have the wrong mic, and change it. Whereas if they have the wrong microphone and you don't know what color it or which microphone it is, you may spend 5 minutes, especially if you've got 10 microphones, trying to find the microphone that they have arbitrarily picked up. And of course, the other microphones that are up pick up signals like people talking badly about people backstage, or worse than that, going to the bathroom, or there's all, a microphone is still a microphone. It still works. You bring it up, you hear what it hears. One of the things that people don't realize is that there's a way, there's a little button I did talk about on the mixer, is called a monitor button. You can, through a headset, monitor any source. So if you're unsure of where you are in the queue, you can hit monitor and put headphones on it, and it will play just on the monitor, so you can queue things up specifically to the queue before you send it out. And again, you have to make sure you're taking the monitor off before you send it to the line. Yes, moving back a little bit. Anyway, so handhelds have some sort of system, and then of course body mics. You always want to wrap the body mic. Unfortunately, the easiest thing to find, most plentiful thing to find that doesn't allow moisture to go through is a condom. And so in most situations, the person who's the soundboard operator will have a whole bunch of condoms around just to wrap body mics in, because the condom allows the sound to go through without distortion, but doesn't allow the sweat and other things that are going through to influence the condenser mic that is the microphone on your head. Typically, nowadays, people have little ear bobs that they can put in for body mics. It also is good to put them here on top of your head, because people don't, when you're kissing and hugging and things, these can get in the way. Putting them here definitely gets in the way of that sort of thing. And so this is just safest to put them, especially if you have a wig, put it in the bald cap. If you have two, again, left and right, put one on each ear, yes? And again, you have your body packs that are part of your costume. There's a little picture of a shotgun mic. Shotgun mics typically are 2 or 3 feet long, and that's for picking up a sound a long way away. If you've ever it doesn't quite work the way it does in the movies, where they're a mile and a half away and they can pick up some sort of individual sound. It doesn't quite work that well, but it does work pretty well. Cool. All right. Again, not a lot of in-depth stuff. Probably more in-depth stuff than you probably wanted, but just a little introduction to how sound works, the way the system works, and a little introduction, so that in case somebody ever says, "Do you know anything about sound?" you say, "No, Bill," and then call Cody. All right. All right, we'll see you next time. Project 4, see you next time. We'll see you then.
In an ideal world, I start with a blank palette, and then I get to slowly add in all of the ingredients to make the world real. I'm Robert Kaplowitz, and I'm a sound designer. On every show, sound designers are responsible for putting together the sound system for the show, whether it be a musical or a play. And then sound designers are also responsible for the sound content in a play. So on a play, I often write music and also sound effects, but also I'm then responsible for the reinforcement, for conveying the sound of the orchestra and the singers to the audience in a way that actually connects the audience to the fundamental text of the play or the musical. The whole idea is that we are trying to sculpt an environment that you're not deeply conscious of for the most part. In a musical, the old joke is with the sound designer, if you notice the sound design, it's a bad design. In essence, the sound designer is trying not to be noticed, while still very subtly often affecting you. I can draw attention to a moment in a play by taking sound away. So sometimes I'm a silence designer. I kind of became a sound designer because I realized it was the thing I did best. I did theater in high school. We had a technical theater class, and so I took the technical theater class and I fell in love with the theater, and I had gotten into electronic music. And so I was doing all of this sort of really, sort of getting into esoteric sounds. And then, so with all of that, I then went to college. I was able to study design as a conceptual art. And when I finished college, I went out and I was doing, you know, anything I could to pay the bills, of course. And I was doing sound design and lighting design and set design. And as my work evolved, I began to realize that I didn't care enough about the details of lighting or scenery. But at the same time, computer editing was just coming out. And I remember spending hours zooming in, you know, to 1,000th or 1,000,000th of a second and literally seeing the waveform and going, oh, if I edit it right there, it'll sound perfect. And I said, oh, well, that's what I care about. That's what I'm excited by. There was a march, I remember, what I remember most clearly, I think it was March of 1995. And it was the first month I earned my entire living as a sound designer. And I designed 5 plays in 1 month. And I think it was a $300 fee and a $200 fee. And I remember thinking, oh, I've actually done it. I've earned my living as a sound designer for this month. In order to be a sound designer, the very first thing absolutely is to listen. But I think it's 2 kinds of listening. I think it's listening to what's there, and it's also listening to what's not there. It's listening to the space where you want to add, where you want to make more. What I'm working on is a production of the play is called The Secret of Sherlock Holmes. If you're a Sherlock Holmes fan, you'll know he plays the violin. What I'm trying to explore is the idea of making textures out of the violin that aren't necessarily music per se. I think that my primary value as a designer, you know, far above my composing skills, far above my listening skills, is my ability to read a play and understand what it is, and what it's about, and how to help the audience connect into it. So when I'm working with a play that has a lot of sound dictated by the text, that's of course where I start. I want to make sure that I'm giving whatever the world of the play requires. Anything from, you know, this guy's a cellist to there's dogs barking and trash cans rattling in the alleyway. The thing that gets interesting about that is how do I take that to an artistically interesting level? But sometimes what's interesting is how do I transform that sonically? Do I make it, you know, can I make it rhythmic? Can I make it tonal? Can I find a way to make whatever these sounds are more connected to this particular world? This show that I just did with Annie Kaufman called This White Night, I made music out of refrigerators. That's just your refrigerator droning. I took refrigerator drones and I recorded them and I put them in a sampler, which is a program that allows me to play sounds musically. And I wrote a score out of that. And I can have multiple samplers. You know, as sound designers, we get the freedom to play with that. And again, working in a way that the audience doesn't even know is happening.
Get ready, pause!
When I'm doing a musical, I'm in no way responsible for the music. You know, on a musical, you've got an orchestrator, you've got a composer first, you've got an orchestrator, you've got a music director, you've got a lot of people on that team already who know very well what they're doing. And then there's me, and my job is to figure out what they're trying to achieve within the score and find a way to bring that to the audience. In Fela, one of the things that I was really interested in doing was creating an environment that the audience was immersed in the sound, in the music. And that wasn't the music team's job, that was my job. That we were working in a Broadway theater there. And so the Proscenium Arch feels like an obstacle to some degree. And one of the things, you know, Marina Dragici, who did the set, really managed to pull the set into the house. And Robert Wurtzel, who lit it, and Peter Negrini, who did the projections, all of them did a lot of work in the house. And I wanted to do the same thing, so that I created a sound system that could allow us to do a full surround of the vocals and the band without it ever seeming like the actors were behind you. And how do I do that, still maintain the power of Afrobeat, still give us a really clear sense of where everyone is in the room? So how do I do that and still embrace the audience, wrap the audience with the sound?
And the Tony Award goes to Robert Kaplowitz, Fela.
I'm insanely grateful to have been a part of a company that made art. So to Sunil, to the Fela company, thank you. I think one of the reasons I love sound design is it gives me a chance to make an art that I am good at and that I love making in company of others. it's like a fission, like a nuclear reaction in this very positive little tiny way, where a bloom of energy is created and a bloom of artistic creation happens. Is that I get to do it live, and I get to have the response, and I get to let the design and the soundscape, the score, as it were, develop in collaboration.